Hello everyone, today we'll be going over section 3.1, defining rational numbers. So just a reminder that integers include whole numbers and negative whole numbers, which can be positive, negative, or zero. And the set of integers is denoted by the symbol z. And the new definition is the definition for rational numbers. A rational number is a real number that can be written in the form of a over b, where a and b are both integers and b cannot be zero. Why can't b be zero? Well, because b is the denominator. The fraction line can be seen as division as well. A number divided by b. This is what it means, right? So if b is zero, then you're going to have a number divided by zero, which is undefined, right? So that's why b cannot be zero, denominator cannot be zero, okay? And so rational numbers include decimals that are either a terminating decimal, so it can be a terminating decimal or a repeating decimal. Now, you guys might not understand what terminating decimal means. Terminating decimal just means a decimal that stops. Okay, so for example, 3.5. This is a terminating decimal because the decimal end. Okay, and just a note that all integers are rational numbers because all the integers can be written in the form a over b. Let's just say, for example, 5. 5 is an integer, and 5 can be written as 5 over 1, which is an integer over another integer, right? A over b, where a and b are integers. So 5 over 1 works. All of the integers can be written in the form of a fraction a over b, so all of the integers are rational numbers. Okay, and now we denote rational numbers using bold Q. So a Q with a line here. Okay, our first example is to organize the numbers into rational numbers and irrational numbers. Not rational is called irrational. Okay, so first one, negative 42, it's an integer, so of course it will be a rational number. The second one, 75.082 and then 106 repeating. The bar on top means it's repeating. So what it means is that this number will look like 75.082, 106, 106, 106, etc. So this satisfies the condition of repeating decimal, right? So the second number is a rational number. Okay, and then root 3. Root 3 is not a rational number. The reason is that if you are trying to find its decimal answer, it's equal to 1.632050, etc. And it's a non-terminating decimal. It's not stopping, and you don't see any pattern here, do you? So it's not a repeating decimal. So it will be a irrational number. Okay, next one, 98 over 16. This will be a rational number. It's in the form of a over b, where a and b are both integers. 2.3003, it's a stopping or terminating decimal. 89.3977778 ... This is a irrational number because it's not terminating. It has the dots, it's not terminating, and it's not repeating. It doesn't have any pattern that you can see, right? Next one, pi. Pi, again, not rational. Pi is 3.14155926, etc. Not ending, not terminating, and not repeating. You don't see any pattern, so it's not a rational number. It's irrational. Okay, and the last one, 8, an integer, so it's a rational number. Okay, so that's the definition of rational numbers and irrational numbers. Okay, next one, we're gonna learn how to change from a decimal to a fraction and a fraction to a decimal. Okay, so first one, to change a fraction to a decimal, you're gonna divide the numerator by the denominator. And so just a reminder that the numerator is the top number and the denominator is the bottom number. So numerator, denominator. Okay. So divide the top by the bottom. And so for example, the first one we have here is 3/8. If I want to change it to a decimal, what I'm gonna do is I'm gonna divide the top by the bottom. So you're gonna do top divided by bottom. And to use your long division, you're gonna put the bottom number, put the denominator, the bottom number out here. The bottom number going out, okay? And then the top number will go inside. So 3 is not divisible by 8. 3 is not enough, so I'm gonna add a 0 here. So 30 is enough. You can have 3/8 going into 30. So then we'll have 6 left. I'm gonna add a 0 here. So 60. 7 times 8 is 56. And then we have 40 left, and 5 times 8 is 40. Okay, so 3/8 is the same as 0.375. So you're basically just dividing the numbers. Okay, the second one, -2 and 5/6. So this whole number here, we can just write -2 for that one, for that part, and then this fraction part will be the part, will be the decimal part for the decimal. Okay, so we're going to divide 5 by 6. So bottom number goes out, so 6 is here, and then 5. 5 is not enough, so add a 0, so 0 point. 8, 48, and then 20. 3 times 6 is 18. So 20, 3, 18. And then you can see that there's a pattern here. It's always going to be 20, and 20, and then 18, and then 2, 0, etc. Right? So we know then you're going to have 3 repeating. So this is 2.8, 3 repeating. Okay, next example is to change from decimal to a fraction. And to change from a decimal to a fraction, if it's a terminating or a stopping decimal, you're going to look at the last place value. So this one, last place value. And you can see that this place value is the hundredth. Hundredth. So, which means it's gonna be the number over 100. Okay. So, oops, 100. So that would be the number over 100. Okay, and if your number is a repeating decimal, it means that it's going to be over 9, 99, or 999, etc. So this one is a repeating decimal. So it will be 1 and 2 over 9. Okay. So because it's 2 repeating, so it's 2 over 9. If it was like 21 repeating, then it will be 21 over 99, etc. Okay, next we're going to talk about the inequalities. So the symbols we have here is greater than, this side, greater than or equal to. So greater than with a little line here means equal to. Less than, facing right, and then less than or equal to with a line here. And so inequalities is used to compare numbers. Okay. When you are comparing decimals, you're gonna compare them with the same number of decimal places. And if needed, you can extend the decimal. For example, when you have a repeating decimal. We'll see some examples later. Okay, and if you're comparing fractions, you'll need to change the fractions to equivalent fractions with same denominator, common denominator, and then compare the numerators. Okay, and just a note that the number further on the left of the number line is smaller. Let me show you an example. For example, 0, 1, 2, -1, -2. If I'm comparing -2 and +1, which one is further on the left? Of course, -2, right? And we know that -2 is smaller than -1. So the number further on the left is always smaller. Okay. Now let's do some examples together. The first one, 0.6 repeating and 0.6. If we want to compare these two, having one decimal place is not enough. So I want to extend the decimals. So I know 0.6 repeating, if I extend one more decimal place, it'll look like 0.66 repeating. And then, oops. And then 0.6 is the same as 0.60. Adding zeros after the decimal place, after the end of a decimal is fine. You can add as many zeros as you want. Okay, so which one is greater? Of course, 66 is more than 60, right? So it will go, you will have the greater sign. And the opening of your inequality is always towards the bigger number. Okay, the opening is always towards the bigger number. Okay, next one. So again, it's the same numbers except that the numbers are negative. Now, negative 0.66 and negative 0.6, which number is further on the left? If you think about the numbers on a number line, negative 66 will be further to the left comparing to negative 60, right? So then the number that's further to the left will be smaller, so the opening will be facing the bigger number. Okay, next one. This time we have two fractions. To compare fractions, we're gonna change them to equivalent fractions with the same denominator. And the common denominator here we can have is 56. So we're gonna multiply to get 56. So we need to multiply by 7. 5 times 7 is 35, and we're gonna multiply by 8 for the second fraction. So it'll be 32. And so after you have the same denominator, you're gonna compare the numerator. Is 35 bigger or 32 bigger? Well, of course, 35 is gonna be bigger, so your opening is gonna be towards 35, so going that way. Okay, last one. Well, again, same numbers, so let me just write numbers down. Now the denominators are the same, you're gonna compare the numerator. Is negative 35 bigger or negative 32 bigger? Well, of course, negative 32 is going to be bigger because negative 35 is further to the left. So that will be your inequality symbol. Okay. All right, last two. Well, actually, one more. Okay, this next example is order from least to greatest. So to order from least to greatest, there are two things you can do. You can either change them all to fractions, or you can change them all to decimals. So for example, the first one, because the first four are fractions and there's only one decimal, so I'm going to change everything to a fraction. Okay, so negative 0.6 will be negative 6 over 10 as a fraction, right? So now, to compare fractions, you need to have a common denominator. And so we'll have 3, 8, 4, 6, and 10. To find the common denominator, it's actually 120. So we're going to change all of these fractions to a fraction over 120. 1, 2, 3, 4, 5. Okay. So to change the first one to over 120, you need to multiply both the top and bottom by 40, 40 over 40. So 30 times 40, 120, we'll rule that down already. Negative 1 times 40 will be negative 40. And then the second number, we need to multiply them by 15 over 15. 7 times 15 is 105. And then the third number, 3 over 4, to change to 120, you need to multiply by 30 over 30. So that will be, let me just write it. So that will be negative 90. And then the fourth one, you're going to multiply by 20 over 20. That's 100 over 120. And the last one, 6 over 10, so you're going to multiply by 12 over 12. So that's negative 6 times 12 is 72. Okay. So now you have all the same denominators. You're just going to compare the numerator. Which one is the smallest? Smallest one will be the one furthest to the left, which is negative 90. That's the smallest one. And then the next one will be negative 72, and then negative 40, and then 100, and positive 105. Okay, so now that you have these in order, you need to order the original numbers, these numbers from a question. So that will be, the first one is the middle one, negative, let me use a different color. Negative 3 over 4. The next one, negative 0.6. Then the first one, negative a third. And then 5 over 6 and 7 over 8. Okay, so that will be your answers. Okay, and so that's it for the first example. And then for the second example, because all of these numbers, well, most of the numbers are decimal, only one fraction, so we can change that number to a decimal. Change to a decimal. So 21 over 5 is actually just equal to 4.2. So then we'll order from the least to greatest. Least will be negative 4.8 and negative 3.9. Negative 4.8 is the smallest, and then the next one will be 3.9. The next one, 2.1, and then 4.2. This is 4.2, and the last one will be 5.2. That's the largest number. So you're going to write them down. Negative 4.8. Next one is negative 3.9, 2.1, 21 over 5, 5.2. Okay, so that's your answers. Okay, moving on to the last example. Determine the decimal rational number between each pair of rational numbers. So basically, you want to find the decimal that's in between the two numbers. Well, it's a fraction, so it's kind of hard to find a decimal between them. So let's change them to decimals first. Okay, so this one, negative 4 over 5. So 4 divided by 5.8. So this will be negative 0.8. And this one, 5 divided by 6, 6, so 0.8, 48, 20, 3, 18, 2, and we'll know that it's repeating, so negative 0.83 repeating. Okay, so I want to find a number, find a decimal between these two decimals. How do we do this? Well, we can extend the decimal by one more place value. So that would be negative 0.80. And then the next one we can just leave it as negative 0.83, because we need to have same decimal places in order to compare them. So a number between these two, we can have, for example, 0.81 or negative 0.81, negative 0.82, negative 0.83. Negative 0.83 will not work. Well, it actually will work, but we'll just leave it as negative 0.81 and negative 0.82. You can choose any of them. Okay. And then the second example, 3.5 and 3.6, we can extend it to one more decimal place. So that's 3.50, and then 3.60. And so numbers between these two, we can have, so basically numbers between 50 and 60. Well, we have a lot of choice. So we can have 3.51, 3.52, all the way to 3.59. So these are numbers between 50 and 60, right? And there's more choices. If you extend it to one more decimal place, 3.600, then you have more choices. You can do 3.501. So basically numbers between 500 and 600. So 501, 3.502, all the way to 3.599. Okay, you only need one number, but all of these choices will work. Okay, so when you do your homework, please show all the work done, including the side work, so I know that you're not using a calculator, because the quizzes and the tests will be no calculators. So please do not use a calculator. Okay. Okay, so that's it for today's lesson. The homework is listed up here. Please try the homework and let me know if you have any questions.